Michael, thank you for joining me. You are Lorikeet's recently anointed Velocity Tsar. Um, what is that?
Yeah, that's a fantastic question. I've been trying to
Oh,
figure
thank
out
you.
that myself. Uh, it's a mix of basically how can we move faster across almost every function via using the latest and greatest models. Um, in particular, the a few things have like sort of coalesced together to make quite a substantial change in what you can do with these agents or AI in general. Um, there's just like the models have progressively gotten better, especially reasoning models over the past year or so. Then it's easier, like there's sort of like agent harness of like you have these models, um, and people are sort of used to them as just like you send a message, they reply, you send a message, they reply. Actually, what they do now is they can call tools, basically just take an action in the real world. They can call hundreds of tools before they get back to you. So it's no longer like you reply, they reply. It's more like you reply, they talk to themselves, they take actions, possibly hundreds of times, and then they reply. Um, and those actions can be searching the web, they can be searching internal documentation, they can be writing code. Um, that like harness, like agent harness, is incredibly powerful, and it's combined with like better ways to manage your organization's context and instructions and policies. For example, skills as a way to like compose procedures of how to do like a common task in writing have a lot of potential in terms of tasks that previously one could only imagine as like a human could do.
And
That's the
we've
crux of it.
thought at, we've kind of thought at Lorikeet a bit in the last year about like having an internal AI enablement role, and really intentionally didn't do it because my take for a long time was like I really don't want to hire someone whose job is just to tell everyone else to like draft their emails with ChatGPT. Um,
Yeah,
like that seemed just like a dumb idea. I think the thing that we feel like has radically changed, and I think you came to me in December to say this, and I was like, I know I've been waiting for someone to say this, which is that like probably with the most recent Anthropic Opus release, so Opus 4.5, there has been some kind of tipping point in the ability of an agent to run for a long time to achieve a goal, but also to like not go down weird paths and do weird things in doing
yeah,
that. And part of the reason I think we wanted to say, let's grab Michael, who's sort of already been on the cutting edge of this, and like give him a responsibility across the company, is it feels like this is a moment for everyone to rethink how they do things really radically. It's not a moment to like incrementally use ChatGPT to like research stuff. It's a moment to like be like, hey, how do we completely change how we serve our customers and build software and do work? And that feels like
yeah.
having a focusing person to drive that change is worthwhile.
I think the tipping point in my mind has been I can now sort of trust their judgment. So before you
Yeah.
could write like a long detail, like here's how you do X, here's how you do Y. Do not do X, do not do Y, and it would be it would get it right like 70% of the time or 80% of the time, which is low enough that you have trust issues. You still want to review it manually, and every time you have to review something manually, it's not actually that much of a time saver. It's like saves you 10% of the time doing the first draft. But now, if you can codify these rules or best practices or procedures, it's like 99.9% of the time it gets it right, and it's it's so accurate that like you can take your hands off the wheel and let it run. And now so the problem becomes sort of meta engineering of like instead of building the thing, you are building the thing that builds the thing. And so you're focused on like how do you do this task instead of using AI to do the task. It's how do you do this task, writing it down, and then letting it do like go as autonomously as possible the full task. Because now we're at the point where
And
like
actually,
if you can codify like the rules, the judgment can just be applied. Like you can trust the judgment out, and the judgment can just be applied very cheaply, very quickly on almost everything.
and I think the way that you've approached this velocities are role draws on that and is worth calling out, which is like treating it as a problem of meta engineering, um, not primarily as a problem of say like change management. It's just like actually no, the problem is how do we go change our code base, but also like lots of our other ways of working so that people can be hands off AI agent first, but still be confident that the outputs will be good. And maybe a thing to kind of pull up here that is an obvious question I think a listener would have is like, hey, Lorikeet's product is sort of infrastructure. Like we handle customer support for people at very large scale. Therefore, it has to be reliable. And like we can't take risks with kind of screwing it up or messing with reliability. How do you think about that? Is there a trade-off here? Are coding agents actually going to make us more reliable? Like how do you think
Yeah.
about that risk
The
set?
the thing I've been most excited about is actually using agents or coding agents for testing more so than actually writing the code. I think they have gotten like progressively better at writing code, but the sort of like big change only happened in my mind. I was like, oh, I can get them to test the code, and now I can just review like the test at the end and be like, this makes sense. I'll usually, if it's like a big sort of code change, I'll still do it manually, but it's like 99% of the time it works. As opposed to 6 months ago when I would make a big code change and 40% of the time would work, and then I would have to correct it and so on. So it's really um, giving these coding agents or agents in general just the tools to verify its own work and test, and that's how you can get it to be much more reliable. So to give an example, a lot of the work inside Lorikeet is say setting up tools. So setting up tools that Lorikeet can use, and often that's quite a tedious process. Like here's some open API spec. Um, Previously, a human would have to go in and add it to our platform and then test it, and then is that the right result? Well, then they would change it and then test it again, and change it and then test it again, um, and like okay, you made a small change. Like, what if there's 10 tools? Do we go in and test all of them? And now the browser use isn't quite there yet in my mind. It's pretty good, but it's not quite there yet. But like giving access to the raw APIs or raw tools to like create tools and then test tools means that
And
you can
verify.
have very
Yeah.
high confidence that like given an API spec at the end, it's like I tested all these tools. Here's what I got. Is that what you expected? Um, and so it can be more reliable because you can make one small change and then test everything. Whereas in practice, a human is going to like test one or two things and be like,
Mm.
I have better things to do with my time.
One thing I've been thinking about is as the intelligence of AI agents um, reaches the intelligence of humans, all of the thinking and work we've done over many years to think about how to work effectively with humans becomes more and more relevant. Like in some ways, it's actually much harder to manage a massively subhuman intelligence than it is to manage a human intelligence, because actually, like a lot of our systems are built to work with human intelligence. And I think one of the things that I found productive when I think about reliability is to ask, like, okay, what causes poor reliability when the team is all humans? And what tactics do we use to address it? And then in many cases, those tactics actually work really well with agents, because the difference with coding agents is they have basically limitless capacity and they don't get bored. So to give an example in software engineering, like a thing you often see is like people make a change, they test it locally in a kind of janky local development environment, and then they push it live, and it turns out they didn't take into account a bunch of edge cases that exist in production that aren't well matched in the local development environment. Well, it turns out a coding agent can do two things that empirically human developers don't bother to do. One is it can make a ton of dummy data in the local development environment, so the local development environment is representative. And then two, it can use its browser to click through and manually test all of those paths and check for any errors or unexpected behavior. And so like that tactic of have a representative local development environment and click through the damn thing and check it works has been a tactic that's been fully available to human developers the whole time, but for reasons unrelated to intelligence they tend not to do. So when you apply that framework, like I keep seeing opportunities where actually like I think our reliability should be better. And so when we talk about some of the debates over the past year about slop or vibe coding and code quality versus velocity, I actually no longer see a trade-off. I believe that done properly, using coding agents should simultaneously increase velocity and quality. I don't think it's inevitable, but I believe that is the right goal.
Yeah, like one philosophy I have is not all code is created equal. There was some code in a code base which is incredibly high risk, and even today I would still be hesitant just vibe coding it or changing it. But there was a lot of code which is very low risk. And in particular, there was a lot of code to do with testing, um, which is very low risk to change because you can sort of, this thing works currently. Do the tests say it works? Still works after you add more tests, and that's where you can get a lot of power for it, making it reliable. Like um, there were historically we have kind of underinvested in this testing setup because we've kind of like manually tested and so on, and just so much effort to write these tests. But now it becomes just a lot cheaper, and we can add more tests for edge cases, which previously it's like, well, it's unlikely to change. You could just add it as well. And an interesting side effect as well. The reason why I always go about testing is uh, every time we have like a big step change in something, there's always a new bottleneck. So in software development, historically, writing the code has always been the bottleneck. I would say I spent like 80% of my time a year or 2 years ago writing code. And then like manual testing wasn't a big deal because it's like 5% of the time after all that big slog. I'm like, yes, it works. And now it's kind of gone from like 5% of the time to 50% of the time, and the job just becomes QAing. And
Yeah.
now like, well, that's a new bottleneck, and so you can then, you know, as the bottleneck has shifted, it's actually focus on testing as well, so that you can get make that 50% back down to 5%, and then I don't know
I think
what was been the first
the other the other vector I'm seeing for quality improvement is actually like not quality as measured by reliability or correctness, but quality as measured by goodness. And historically, a bottleneck for improving goodness is the time for people with taste and intelligence to go and dog food the product and think about whether it is good and how it can be better. And a flow that I've been getting surprisingly good results with in a skunkworks product that we're building at Lorikeet at the moment, watch this space, um, is actually saying to the agent, hey, go through this flow in the product. Here's your goal. You are an expert on user experience design. Go through this flow and write out extensive feedback about everything here that's not world class. So it goes through and does that, comes back with its report. Maybe you chat to it, maybe you get it to reflect. And it's like, cool, go and create linear issues for all the gaps you identified. All right, now go and solve all those linear issues in parallel and close those gaps. Now do it again. Imagine that its taste there is, we're not going to say it's the best in the world, but let's imagine that it's approximating a decent, competent product manager who's clicking through and writing their little friction log of the issues that exist. In many cases, the barrier to goodness is not that um, your basic competent product manager has been through every part of the product and that their ideas were basic and competent and not excellent. Actually, your gap is that there are huge swathes of your product that like no one has really put a second set of eyes on and your users have been struggling with, and like no one's prioritized it. And even if they prioritized it, they wouldn't bother because if they wrote the world's best friction log, it would still sit in an engineering queue. And now you can actually just dispatch these agents to go do quality improvement and quality suggestions on any flow in your app as much as you want. And the limitation now becomes your ability to spawn them and review their work, which I think is another cool vector for quality of just like doing more goodness evaluation and sort of improvement.
Another dimension of that is historically like almost every product is in some stage of migration. Like they've changed some
Right.
component, or like there's depending on what page you're on, there's like three different search bars which aren't quite the same, or there's a slightly different table design and so on. And
Yeah.
before in a very large code base, you would have to like you change the design system. Now you have to or with the design system. Well, people aren't using the design system. So you've changed the design system, and now you have to like tell every team, hey, can you please like use the pattern we just created so that the product is more consistent. And now, if you can write down, like, if you can codify, like this is when you should use this table design or this search bar design, you can very autonomously, very accurately just bulk apply that pattern across the entire code base.
Yeah.
And usually, like those changes are fairly low risk because it's um, the, the 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 agents are like sort of can follow these instructions incredibly accurately now, so that you know it gives you one PR to like update one search bar, and it's you change it works 99% of the time. So those like UI migrations like choose to take a lot of engineering hours, at extremely low cost. So you can
And
with
so
the
one of
product.
the and one of the meta things here is, as product builders, we've built up kind of a career worth of intuitions about how long things take and therefore what things are worth doing. And all of those intuitions are back up for grabs. I think there are many people who looked at, UI componentry inconsistency and said, oh, it annoys me. I bet this is janky and inconsistent in a bunch of places. I just don't think it's worth trying to get that onto a backlog or trying to disrupt in-flight work to do this. And so it gets left alone. And the thing that's interesting about intuition is often it operates at the subconscious level. So, like, the reason you ignore the inconsistency when you see it in the app is that your lizard brain tells you, like, don't bother. And so there's this interesting aspect of retraining ourselves about what we pay attention to and what our intuitions are about the types of problems worth solving and worth not solving. But maybe a cool example of that, Michael, was just before Christmas, I think you shipped a kind of conversation testing experience in line with our kind of Lorikeet concierge training UI. And I'd been saying in meetings, like, I thought that was sort of an example of like a faster horse request. And actually, we wanted to bet on simulations, which someone else was building out. And the point you made, which I thought was a good point, was like, actually, it only took you 2 hours to build that feature. And so, like, it's actually good to have both because then people can manually test as well as kind of simulating. But like, I had been thinking I was making this great, profound point of like, don't bother building that. It's a faster horse feature. Just spend the time on the step change feature. And you were like, well, hang on, the constraints are totally different. Like, if it's only 2 hours, it is worth doing. And I was like, yeah, of course it's worth doing if it's only 2 hours. And I think when you come across a realization like that, it makes me think there's got to be so many more of those cases where we've just been getting these trade-offs wrong.
Yeah, like that has been something we've been toiling about. Like, oh, wouldn't it be great to do this for like at least a year? It's been like a constant small feature request for a long time, and it's just like it doesn't make sense if it takes 1 week, but it makes sense if it takes a day. Um, and that like so yeah, the trade-offs are completely different. Um, I also think that
Or I think importantly
people,
on that day thing, like, there's the difference between time on task and wall clock time. So um, an example is like, you may have something that gets compressed to a day, but if it turns from a day of hands-on keys work to dispatching an agent in the morning and reviewing its work at midday and then approving in the afternoon, that is also a step change.
yeah, 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 exactly. And I think sort of like the intuition is no one quite understands, like people, especially non-technical people, don't really know. They've probably got like years of talking to engineers about like, oh, this thing is really easy, this thing is really hard. And there were still some things which are really easy and now they're really, there's still, sorry, there were still some things which were really hard and still really hard. But there are also things which are really hard and now like quite easy. Like there was an XKCD comment of like, oh, you want to build an app where you recognize the type of bird, and well, that will take you 5 years. Now it will take you a few hours because like image recognition is extremely good, and building an app is now that can just recognize birds is actually extremely easy. Um, yeah,
The um
so
the funny
the
the funny
sort of rules of
example
engagement are
the,
quite different.
the funny example of this is that coding agents are trained on obviously code bases and documentation about coding, but also about human discussions about doing coding work. And one of the funny outputs of that is you'll often see if you ask Claude Code to plan out a feature or a project, it will say things like, near term, today we should do this. In the next month we should do this. Or it'll say, hey, my estimate for this feature is 4 weeks, and here's my breakdown. And obviously, like, those estimates are wrong, but also it has no concept of time and it can maximally parallelize. And so if you probe it, like, where is this estimate coming from? It says, oh yeah, I was trained on a bunch of human
Yeah,
discussions. So it's very funny that, like, these intuitions about how hard things are not only in our minds, they're actually also in the coding agent's mind. And I think everyone who's used them has had that funny experience of getting told, a thing you've asked it to do will take 2 weeks and then it's done 2 minutes later.
yeah. There's a sort of an outdated view of software engineering as like a factory line of just like you create issues or tickets, you give a time estimate, then 2 weeks later it's done, it gets handed off to an engineer and done. That was already kind of broken. Now it's completely broken because it's like literally it's so hard to give an estimate. It was previously hard to give an estimate on how long a geo ticket or linear issue took. Now it's essentially impossible. The coding agents can't get coding agents won't help you there because they're trained on like the old world, and so
Yeah.
they have no idea. And It's
Well, I
because
think
the
what it
models are also getting better at quite a stable rate. It's also like what would have taken 2 hours, 2 months ago might take 1 hour now.
I think what it's meant is that effort estimations have actually become much more bimodal. So previously, if you gave a spec to an engineer, to a range of engineers, and asked them how long it would take, you would get a normally distributed estimate of the time. Now, what it means is for a given task, the task will either be solved pretty trivially by a coding agent in between 1 minute and 1 hour, or it won't be solved by the coding agent at all, in which case it will need to be done by a human. And probably the fact that it couldn't be solved by the coding agent means it is really hard or maybe impossible because of sort of architectural constraints, in which case it will take forever. So like now your estimate for a task is sort of like a spike around 1 minute and then this spike around like 1 month. And that exactly to your point makes it very hard to estimate now because a given backlog of work could potentially all be done in an afternoon or like never done. And in some ways, especially at the moment, until you try, like you actually just don't know.
Yeah, yeah. One thing I want to emphasize is we've talked a lot about software engineering, but I think it just can apply gradually. Oh, sorry, everywhere. Um, Claude Code is called code, which people think means it's for software engineers, but it really can do anything. One example I found funny was, uh, you know how if you wanted to send like a Slack message to everyone, you'd have to like write it, copy paste it, change the name, write it, copy paste it. Someone sent me a Slack message today, and I said I used Claude Code to do this. They're not an engineer, but they had told Claude to like send a message to. I would say what it is. It's for surprise um, to most people in the company, um, and obviously much easier because they didn't have to copy paste and change the name like 50 times.
Yeah. I mean, I was saying in a previous meeting today, I have a flow set up where I've got Claude Code integrated with my email, with my calendar, with a bunch of other stuff. But one of the workflows is if I have inbound from a VC fund, I'll get Claude Code to research the fund, figure out who we're talking to, figure out how much we want to prioritize it, and then if I can't take the meeting, I'll get Claude Code to reply to the email as me, CC in our chief of staff, and then ping him on Slack with context about why it is and what it's happening. And then he was saying that he uses then Claude Code to read those messages and reply back to me via Claude Code. So we now have like warring Claude Code Slack instances having conversations with each other. But I think uh, this point you're making about the application beyond software engineering is critical. And actually, like the bleed between software engineering and other things has always been big, and this makes it bigger. So, for instance, going from, hey, analyze all the meetings we've had with this customer about this problem, think about the right set of solutions, turn that into issues in linear, take the issues in linear and turn them into pull requests. Like that bleed can now be done from not just one person, but one terminal instance. And that's very cool. I think that opportunities to do deeper level of analysis and introspection are very big. So the ability to go and say, hey, we're working on this feature for this customer. In the last month, have any other customers mentioned a similar need? Great tool to have, trivially doable now. Again, historically, it's not that your PMs were doing this and they just weren't good enough at it. It's just they weren't doing it. They didn't have the time. And so this ability to take a approaching human intelligence and dispatch it to do a bunch of work can really improve quality a lot, I think.
Yeah, yeah, or
Uh,
even just a below average software engineer that everyone now has access to is incredibly powerful. I'm always amazed as a software engineer how many, like, oh, this there's a classic thing of just like, oh, this thing could be trivially automated by a shell scripts, but that company can't afford to hire a software engineer, so they just or they don't think
it
to
just,
hire us, or like, what
yeah,
software engineer wants to work for a dental office? And so they just get used to
yeah.
pain of just human doing something really repetitive. And now everyone can do it. For me, the
So I
biggest
was,
like mindset shifts has been like um, these models are really good when the task is verifiable. And like historically, people have thought of tasks that are verifiable, like maths, as being really hard. Like everyone thinks maths is a hard subject, but actually, maths is an easy thing for these models because it's really
iterate.
hard to verify. It's really it's really easy to verify it's got the right answer or not. And actually, the harder task is like writing. Like everyone thought LLMs would kill off writing, but actually they're just really bad at writing because what's a good essay? Like I've found that
Mhm,
writing documentation for coding agents is actually quite hit
mhm,
and miss, and I have to do a lot of that myself. But it's the getting coding agents to write code is
mhm.
the easier part.
On the point about verifiability, I think one interesting aspect of LLMs is I think they're quite good at applying like relatively well understood heuristics and concepts to unstructured data. The verifiability, like verifying that they've done so correctly is trickier, but actually like they're good enough at it that you can let them go. And it turns out there's a lot of knowledge work that's of that shape where the limitation was actually like being willing to do the grinding because it's not that hard. I was talking to Chris on our BizOps team last week about wanting to go back through sales deals we'd had and figure out like which of them were actually kind of qualified opportunities and which of them were maybe like advancing a bit far down the funnel and therefore blurring our signals about why we win and lose. And historically, like our options there would have been sample and guess, vibe it, or Chris ruins his life and spends 2 weeks reading meeting transcripts or reviewing meeting recordings. Actually, it turns out the answer is just have Claude Code do it. It actually doesn't care whether it has to grind through 100 deals, 200 deals. And then once it's done that and it's applied the relatively simple heuristics about how we want to qualify a deal, we can get an answer back that's quite rich. And at any time we can ask it to show its work or double click on its assumptions or challenge itself. And so that, like we sort of talked about as infinite interns, that's sort of like grunt work that either someone would have had to do and like hate their life for a while, or that you just would never have done now becomes very doable. And that's true in code, but it's true across the rest of the economy as well.
Yeah, one implication is that it really raises, like, even it might not be immediate, it might only be for like software engineers, but it raises people's expectations for what a product should be able to do. For example, because I am a software engineer, I've been using these tools for almost a year now. I sort of expect to be able to like write a prompt to like fix something, fix like a trivial issue that's just like there like 10 times. And I was making a presentation recently, and like things were slightly misaligned, and I was kind of like, where do I type in
You're
how
like,
this works?
where's the window
Just
to say
align them
align?
properly.
Yeah, yeah.
Yeah, align them. And I like, oh, I realized I have to like manually drag and drop things. And
Mm.
like maybe most people are fine with that for now, um, but I think is like soon enough, more people will use these agentic products, not just software
Yep.
engineers, not just for code, and the expectations that products will offer um, these types of like uh, align this type commands will just bleed everywhere. I think.
The other thing I've felt really intensely recently is this like um feeling of incredibly elevated opportunity cost of meetings. Um, Pre some of these tools, if I had a 30-minute meeting about a deal, I might be able to help add some perspective or unlock something or move it along. And if I'd taken that 30 minutes somewhere else, I might have been able to review two deals asynchronously. But if now in 30 minutes I could go through, every open deal we have closing this month and spot the ones with issues and kind of jump in and help or ask challenging questions or link the right product team in, then that 30 minutes to review the deal feels like almost irresponsible. And I don't have an answer to this yet, but I've really wrestled with how does this need to change the way that I spend my time and that we as a company spend time? Because in some ways, like any time you're like deprived of being able to use the terminal to do things, um, you're now you're now facing this way higher opportunity cost. And I don't know what to make of it because I think on the flip side, like human connection, human creativity, the ability of people to connect with and inspire each other in some ways becomes more important because everything that can't be done with that is now going to be trivially automated. And so, yeah, that's a tough one. I haven't figured out the answer to it yet, but I at the moment just feel a lot of
Yeah.
anxiety when I'm in meetings.
We're running out of time, but I'll just mention one thing, which is I'm very skeptical about claims that someone will be a 10x developer or 10x software engineer thanks to AI, because like if you look at how software engineers spend their time, rarely are they spending 100% of their time coding. And so rarely, if you just give them a 10x coding tool, they won't be 10x faster. Instead, they'll spend 4 hours a day in meetings, and those meetings will be 1x faster. And then, the 2 hours a day they spend coding will be 10x faster. But like overall, because so much of the time is spent in meetings, for example, or doing something that doesn't have that like multiplier, it just means that the productivity is kind of um,
The way that the way
it's
that I
an upper
think
bound.
anyone would end up 10xing would have to be not that they do the stuff they're doing 10x faster, which is the point you're making. It's that they would observe of all of their tasks radically different productivity multipliers, but then they would reallocate their time towards the tasks with the highest productivity multiplier. So I think the way that people will become 10x more is they'll identify that 10% of their time is 20x faster, but then they'll do more of those tasks because of this change in what is now worth doing and what's now valuable, which is like a very unstable equilibrium, and I don't know where it will land, but I have some intuition that like that's the way that the changes would pan out.